Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this trigonometry function problem. So as per the problem, find the following for cosecant x equals 7 for x in this open interval 90 degrees to 180 degrees. So since it's an open interval, x cannot be equal to 90 degrees and 180 degrees, but any value between 90 degrees and 180 degrees. We have to find the values of sine x over 2, cos x over 2 and tan x over 2. Since x lies between 90 degrees and 180 degrees, that means angle x lies in second quadrant. So we can show angle x somewhere here. So this is angle x. Now since x lies in quadrant 2 between 90 and 180 degrees, that means x over 2 will lie in quadrant 1. So there's a very important concept we need to understand to solve this problem. And we know as per the CAST rule, the ASTC rule or all sad turtles cry rule, in quadrant 1, sine, cos and tan ratios are positive. So we should get a positive answer for sine x over 2, cos x over 2 and tan x over 2. Now we are given that cosecant x is equal to 7. The first step is to change the cosecant x ratio into its corresponding primary ratio, which is sine. So we can rewrite the given equation cosecant x equals 7 as 1 over sine x equals 7. We can isolate sine x in this equation by flipping the fractions on both sides of the equation. The denominator of 7 is 1. So if we flip the fractions on both sides, we get sine x equals 1 over 7. We can use this value of sine x to draw the triangle for angle x in quadrant 2. So this is a right angle triangle. The formula for sine ratio as per SOHCAHTOA is opposite over hypotenuse. That means the length of the vertical side in this triangle is 1 unit and the length of the hypotenuse is 7. We can use this information to find the length of the third side in this right angle triangle, and for that we can use Pythagorean theorem. The Pythagorean theorem equation is in this equation, C represents the length of the hypotenuse and A and B are the lengths of the other two sides of the right angle triangle. Let's assume A is equal to 1. We have to solve for B. Now we can apply square root to both sides. I get B equals square root of 48. We have to consider the positive case only because side length cannot be negative. We can simplify square root of 48 as 4 square root 3. So that's the length of the third side in this right angle triangle. Now since we have to find the half angle values for sine, cos and tan, we have to use the cosine double angle identity. For part A, sine x over 2, cosine double angle identity will be We can use the right angle triangle to find the value of cos x. In quadrant 2, cos is negative, and the formula for cos is adjacent over hypotenuse. So on the left side, we can write for the reference angle in this triangle, the adjacent side length is 4 square root 3 and the hypotenuse is 7 units long. We have to isolate sine x over 2 from this equation. The first step is to move negative 4 square root 3 over 7 to the right side of the equation, and that will make the term positive, and we can move negative 2 sine square x over 2 to the left side of the equation, and that will make the term positive. Now we can combine the terms on the right side. The denominator of 1 is 1. We can combine the fractions by finding the common denominator, which is 7. So 1 over 1 becomes 7 over 7. So we get 7 plus 4 square root 3 over 7. Next, we can divide both sides by 2. The 2's on the left side get cancelled out. So we get now on the right side, we have to divide the fraction by 2. So we can write it as a division statement. Now we can change it into a multiplication statement. The denominator of 2 is 1. We can change it into multiplication statement by flipping the fraction 2 over 1 to 1 over 2. Now we can apply square root to both sides. As we discussed earlier, x over 2 lies in quadrant 1, so sine of x over 2 will be a positive value. So for the square root, we can ignore the negative case. So this should be the final answer for sine x over 2. Now we can answer part B. For cos x over 2, we'll use the double angle identity for cos. We got cos x as negative 4 square root 3 over 7. Next, we can add 1 to both sides to isolate 2 cos square x over 2 on the right side of the equation. The ones on the right side get cancelled out. Now we can combine the terms on the left side. The common denominator is 7. Now we can divide both sides by 2. The 2's on the right side get cancelled out. As per the steps I showed in part A, this expression on the left side will become now we can apply square root to both sides. As we discussed earlier, angle x over 2 will lie in quadrant 1. So cos of x over 2 will be a positive value. So we can ignore the negative case for the square root. So this should be the final answer for part B. Now we can answer part C. Tan of x over 2. We can use the trig identity for tan, which is sine over cos. We have found the values for sine of x over 2 and cos of x over 2 in parts A and B. Now we can divide this expression. We can write it as a division statement. Next, we can change it into a multiplication statement by flipping the second fraction. We can cancel out the square root of 14. So we are left with so this can be the final answer for part C. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.